Okay, good morning Year 4 and welcome to Thursday's maths lesson. Today we are going to be carrying on our learning about equivalent fractions. So you may need your fraction rule that we've been using the past couple of days to help you. And there should also be two other resources in the home learning, which is one task sheet and then your banded activity, which you can complete at the end as your independent task. So make sure you've got everything ready to go, you've got some paper, and then we will get started. So I'm going to pop up your do now. So we're going to practice what we were learning yesterday, fractions of non-unit fractions of quantities, sorry. So remember that non-unit fractions have a numerator that is larger than 1. So that's really important for the second step in our steps to success. So remember, we divide the whole number by the denominator and then multiply by the numerator. So hopefully you've remembered how to do that from yesterday, but use the steps to help you. I've also put a couple more challenging questions where you may need to use bus stop division for your first step, or you might be able to use your number known facts to help you. So pause the video, have a go and come back to mark it when you're ready. Off you go. Okay, fantastic. Hopefully you've had a go at all of those. Well done if you had a go at the challenge as well today. So I'm going to pop up the answers for you. So you can pause the screen and mark those before we move on. Okay, so today's lesson we're going to be finding equivalent fractions using multiplication and division this time. So we're going to try and use our calculation skills rather than having to use our concrete materials or pictorial representations. Okay, so we're not going to go through all of our words because they're the same ones we have been using over the last few lessons. So make sure you just stop and recap those if you need to. But if you can remember what they all mean, then we can keep going. Okay, so Joe, Bill and Sarah are sharing a bar of chocolate. So for 1/3, Joe says, I would rather have 1/3 because thirds are bigger than 12ths or 24ths. Sarah says, I would like 8 24ths because it has the highest numerator. It must be the most pieces. And Bill says, I would rather have 4 12ths because 12ths is fun to say. Bit of an odd way to say that you want part of a chocolate bar, but who do you agree with? Do you agree with Joe, Sarah or Bill? So I want you to pause the video to have a little bit of think. And what could we use to represent this chocolate bar to prove who is correct? So pause and have a think and then come back when you think you've got an answer. Great, okay, so hopefully you've had a little bit of a think about that. Let's have a look. So hopefully you've thought about a way that we could represent this to prove it, thinking about our fractions and equivalent fractions we've been looking at over the last few lessons. Why do you think these representations on your screen are not the most useful? So this is Joe's 1/3, 8/24 and 4 12ths. Okay, so hopefully you're thinking that they're not equal. So this one does show me 1/3, this one does show me 4 12ths, and this does show me 8/24, but I can't tell who's got the most chocolate because they're not the same size representations. There's a different amount of circles, so it's going to be really tricky for me to see by looking at that representation who has got the most, because it does look like Sarah has got the most. But if we think about our learning that we've been doing, you might have recognised something to do with those fractions already. So 1/3, 4 12ths and 8 24ths are all equivalent fractions. So we've been looking at this already, but what do you notice about the relationship between the numerator and the denominator? So I have talked about this in our previous lessons, but see if you can remember and have a little bit about a think about what that is. So hopefully you've remembered, looking at this information here, 1 is 1/3 of 3, 4 is 1/3 of 12, and 8 is 1/3 of 24. And then hopefully you've recognised as well the pattern between our denominators is our 3 times tables, 3, 12, 24. So we're missing some multiples in there, 3, 6, 9, 12, okay, and so on. So what we want to think about is always, sometimes, or never, are equivalent fractions denominators always multiples of the same number? So in here we've got 3, 12 and 24. So I have some other multiples in between there that I've just said. So 3, we could have 6 ninths, 15. What other ones can you think of? Are they also equivalent fractions? So what I would like you to do, you might have your fraction wall in front of you. If you don't, then hopefully you can get that up on your screen or have a look at mine. Looking at your fraction wall, we're going to start with 1/3. Are the fractions going to be the same that are all in the 3 times tables? So think carefully about the numbers in your 3 times tables. 3, 6, 9, 12, 15, 18, 21, 24. Now my fraction wall only goes up to 12, but we can definitely prove the pattern. So let's have a look. So I have 1/3 is the same as, is it the same as 6? Yes, it is, because 2 6 are the same as 1/3. My next multiple in the 3 times tables is 9, and I can see that 3 ninths are also equal to 1/3. Okay, and then my 12ths are here as well, which we've already looked at in our question, 4 12ths. So let's have a look if we can see that pattern. So we've got 3, 6, 9, 12, 15, 18, 21, 24. And similarly, we have the numbers on the numerator going up in ones. 1, 2, 3, 4, 5, 6, 7, and 8. So what the children are saying now is the numerator is always 1/3 of the denominator. So 2 can be divided into 6 3 times. 2, 4, 6. 3 can be divided into 9 3 times. 3, 6, 9. Let's check a bigger number. So can 7 be divided into 21 3 times? 7, 14, 21. It can. So that one is correct, that statement. The denominator is always a multiple of 3. That means the denominator, the number on the bottom, is in the 3 times tables. So we've already looked at that pattern, and so far that is true. The numerator and denominator can be multiplied by the same number to find an equivalent fraction. So let's have a look at that in a bit more detail. So if I start from my third, 1 times 4 is 4, and 3 times 4 is 12. So they can both be multiplied by 4 to find a new fraction. Let's check another one. 1 times 5 is 5. And 3 times 5 is 15. So that one also works as well. So I'm going to see if the next fraction in my pattern would work. So I want you to think in your head, which number comes after 24? What would be my next multiple after 24? 24 add 3. Fantastic. Hope you're saying 27. So my next number in this pattern should be 9 27ths. So let's see if that works. So if I was to do 3 into 27, 27 divided by 3. So that goes 9 times. And then if I multiply the numerator by the same number, 1 times 9 is 9. So that one works as well. So this is definitely true so far. So if we look at the statement on the top, in equivalent fractions, denominators are multiples of the same number. So that is always true. So let's look at that in a little bit more detail. Okay, so the numerator and denominator can be multiplied by the same number to find an equivalent fraction. So I've got 1/3 and 4 12ths. So as you can see from my pictures underneath, this one's been split into 3 parts and this one has been split into 12 parts, but the same amount is shaded. It's just that this has got 4 parts, okay? But it's equivalent to what is shaded on this side. Similarly with my bars, my bar models are the same length, but the same amount has been shaded. The bottom one has been split into 12 parts and this one has been split into 3 parts, but the same amount has been shaded. Okay, So let's look if we multiply the numerator and the denominator by the same number. So I'm going to start with the numerator because I have both my numerators, and I think that's going to be a little bit easier to work out. So what has my numerator been multiplied to get 4? 1 times something equals 4. Hopefully you know that 1 times 4 equals 4. So my numerator has been multiplied by 4. So let's just check that this happens to the denominator as well. So 3 times 4, 3, 6, 9, 12. Fantastic. That equals 12. 3 times 4 is 12, so that one works as well. So I know that this is definitely an equivalent fraction. And then we can also check it if we're going in the opposite direction, because it should work with division as well. So let's check our division facts. So 4 divided by 4 equals 1. Fantastic. And 12 divided by 4, let's check that together. 4, 8, 12 goes in 3 times. Fantastic. So if I divide or multiply by the same number, I'm going to find my equivalent fraction. So what I would like you to do now, before we do some more examples of that, is match the pairs of equivalent fractions to their representations. So I want you to think, how do you know? How can you explain it? And can you draw your own representation to show it if you want to challenge yourself? So I've got 2 different representations here and 2 different pairs of equivalent fractions. So I'm going to see which one matches to which representation. So my first one is 1/3 is equal to 2/6. So I know I'm looking for something that is broken into 3 parts and 6 parts. And I should have a 1 and 2 shaded. So I'm going to count the parts. In this one I have 1, 2. And then this one has 1, 2, 3, 4, 5, 6, 7, 8. So I know it's definitely not that one. So I'm going to look at the next one. So 1, 2, 3, and 1 is shaded. Fantastic. So that one shows me 1/3. And then 1, 2, 3, 4, 5, 6. So that one is showing me 2, 6 because 2 are shaded. So I can match this representation to this one because I know that's what that one is showing. Okay. So let's just check the next one. I know I've only got one left, so let's just make sure that it matches. So 1/2, so there should be 2 parts and 2 eighths, 2 out of 8 shaded. So I have 1, 2 parts, 1 is shaded, and 1, 2, 3, 4, 5, 6, 7, 8, and 4. Sorry, there's a little mistake there. So who can tell me then maybe what this fraction should have said? Because there's a little mistake on here. This one is split into 8 parts, so I know the denominator is correct, but how many parts should be shaded on the top there? How many parts are shaded? Okay, fantastic. Hopefully you have figured out that that one should be 4. And also we know 4 is half of 8 and 4 parts are shaded. So 1/2 is equal to 4/8, 4 eighths. Okay, fantastic. So you have a sheet in your home learning that looks very similar. So what I would like you to do is go away. You might want to draw a line, or you can just write it down in your book, write your answers. So matching the 4 equivalent fractions on the top to either A, B, C, or D. And then there's also a challenge at the bottom for you to create your own representation. So remember, they would have to have equal parts. So go away, have a go, and then come back when you're ready. Okay, fantastic. Hopefully you've managed to have a go at that. So let's just quickly match them together. So 1/4 and 3/12. I'm looking for something with 4 parts. So I know this one should have been C because I've got 12ths and quarters. Fantastic. Next one, I'm looking for something in 5 and 15. Ooh, so let's have a look at the bottom. 1, 2, 3, 4, 5, 6. So I know it's not that one because that's not got the right amount of parts. 1, 2, 3, 4, 5, 1/5. And then 3, 6, 9, 12, 15. So this one is B. Okay, 1, 6. So I've already counted. I know this one was 6. 1, 2, 3, 4, 5, 6. 1, 6, and 2 12ths. So that one is D. Oh, excuse me. I slipped. So this one is D. And then finally, this one should be A. So 1/2 and 6 12ths. So well done if you match those correctly. And I'd love to see your other representations on the seesaw if you manage to do that as well. Okay, moving on. So now we're going to look at how we can create equivalent fractions. So on this one here, I have 2/3 and something over 21. So I don't know what the numerator is, but I can use my denominators here to help me. So I'm going to find out what this has been multiplied by, because I know I need to do the same to my numerator as I have done to my denominator. So 3 times something equals 21. I'm going to write that in a little number sentence just so we can work that out. 3 times something equals 21. Okay, so I know 3 times 7 equals 21. So this has been multiplied by 7. 3 times 7 is 21. So I need to do the same to my numerator. So my calculation this time is going to be 2 times 7 equals this numerator here. And I know 2 times 7 is 14. Okay, so let's have a look at the next one. So remember, I need to do the same to the numerators and denominators. This time again, I've got a numerator missing, so I need to find out what has happened on my bottom, on my denominator. So 6 times something equals 30. 6 times something equals 30. How many 6s are in 30? So counting in your head, hopefully you know that is 5. So 6 times 5 is 30. So I need to do the same to my numerator. 4 times 5 equals 20. Good, fantastic. So 4 6s equal to 20 over 30. Okay, what I'd like to do is pause the video. Can you have a go at the next one on your own and then come back when you're ready? Fabulous. So let's quickly look at this one together. So hopefully you have found out how many 9s are in 27. I know 9, 18, 27. There are 3. So I need to do 5 times 3, which is, excuse my handwriting, I'm squeezing in there. 5 times 3 is 15. So well done if you managed to get 15 over 27. Right, let's look at some different examples now. So this time I have this side missing my numerator, but I can still use my division facts to help me. So I know that 32 divided by something equals 4. So how many 4s go into 32? Okay, I know that is 8. 32 divided by 8 is 4. So let's have a look what we can do that same to the top number, to our numerator. 24 divided by 8. 8, 16, 24. That goes in 3 times. So 3 must be my missing numerator, sorry. So let's just check that works with my times tables. So I'm going to do 3 times 8, 8, 16, 24, and 4 times 8, 8, 16, 24, 32. Fantastic. So I know that works because it works with my multiplication as well. Okay, so 3 is my missing number. Okay, let's try the next one together. So it's my denominator that's missing this time, but I can still use my numerator to help me. So again, I'm going to do 28, divided by 4. So how many 4s go into 28? Hopefully you've managed to get 7. Fantastic. Some of us hopefully know our times tables quite speedy. So, I've made a mistake there, silly Miss Jones, so I'm going the opposite direction now. So I've divided by 7, not multiplied by 7, so divided by 7. So because I've divided by 7 on my numerator, I need to also do the same to the denominator. So 35 divided by 7. How many 7s are in 35? Fantastic. Hopefully you have figured out that is 5. So let's just check that it worked with our multiplication. 4 times 7 equals 28, and 5 times 7 equals 35. Lovely. So what I would like you to do now is pause the video and have a go at that next one, and let's see if you've got your division. Okay, hopefully you've had a go at that. So let's have a look. So 42 and 7 are the 2 numbers that I have on my denominator. I'm missing my numerator. So I need to do 42 divided by 7. 42 divided by 7. So that is 6. Well done if you managed to get that. So 42 divided by 6 equals 7. So I also need to divide my numerator by the same number, divided by 6. So 12 divided by 6, your answer should have been 2. So let's just check that that works both ways. 2 times 6 is 12 and 7 times 6 is 42. Well done if you managed to get that one on your own. Okay, let's just have a look at another quick example where we've got 2 missing numbers, because this is going to help you if you want to challenge yourself on Band 3 today. So I have a number missing here. I'm going to use the facts that I've got to help me get that one. So I've got 9/12 in the middle. I know there's a 4, but I'm missing this one here. So I know I can use my denominators here to help me. So 12 divided by 4. How do I get from 12 to 4? So I need to divide by 3. 12 divided by 3 equals 4, or 4 times 3 equals 12. So because I've divided again, I need to do the same to my numerator. So 9 divided by 3. 9 divided by 3, 3, 6, 9 goes 3 times. So 3/4 is the same as 4. And 3/4 is the same as 9/12. So I've already worked out this side. Now I can use this fraction to help me work out the missing fraction on this side. So on this one, it's 27 over something. I'm not sure what the denominator is. So I'm going to use the one here to help me find my missing answer. So 9 to 27. What have I multiplied by from 9 to 27? 9, 18, 27. I've multiplied by 3. So I need to then do the same to my denominator. So we also need to times that by 3 as well. So let's do 12 times 3, 12, 24, 36. Good, fantastic. Hopefully you've managed to do that and get 36. Okay. So the really important thing that we need to remember is we need to do the same to the denominator as we do to the numerator, or the same to the numerator as we've done to the denominator, to make sure it's an equivalent fraction. So make sure you're checking your multiplication and division after you've worked it out, just to make sure that it works. Okay, so let's just quickly look at an example of how we can work out equivalent fractions of our own. So I am going to see what fractions I could find for 3/5. So I know that I'm finding a fraction by multiplying or dividing the numerator and denominator by the same number. So I could pick any number. So I'm going to start with 5. So I'm going to create an equivalent fraction of 3/5 by saying 3 times 5 is 15, and 5 times 5 is 25. So I know that 15/25 is the same as 3/5 because I've done exactly the same to the numerator and denominator. I could also choose some bigger numbers. I'm going to go with 100 this time. 3 times 100 equals 300, and 5 times 100 equals 500. So 300 over 500 is also the same as 3/5. Now I've gone a bit high there, but it's still an equivalent fraction. Okay, now there'll be very, very tiny fractions if I was to match it up on my fraction wall, but it is still an equivalent fraction. I could also choose a different times table. Maybe I could do my 12 times tables. So 3 times 12 is 36. And I know 5 times 12 is 60. So 36/60ths is also the same as 3/5. So when you get to your apply questions today, you're going to have a go at doing that yourself. So as long as you show you're working out, it's going to give me an equivalent fraction. I'm really sorry, I've wrote 5 there instead of 12 times 12, because I have to do the same to the bottom and the top. Okay, so for your independent task today, you have a banded sheet. Now, you're going to be starting by finding the equivalent fractions. If you're feeling really confident, I've put 3 for band 3, and some of them might be a little bit tricky. So look really carefully and think about how it has been multiplied or divided. And there are quite a lot of reasoning questions today. So if you want to challenge yourself by doing some different bands as well, not just one of the bands, that would be absolutely fantastic. If you're finding it a bit tricky, make sure you go back on the video and watch the method of how I've worked it out. But remember, the numerator and denominator need to have been multiplied by the same number for them to be the same. Okay. Okay, enjoy the rest of your day, everybody. I can't wait to see your work on Seesaw later. Do your best and good luck. I'll see you tomorrow. Bye.